Welcome to this video on Boyle's law. Boyle's law describes how pressure and volume are related for a fixed mass of gas at constant temperature. As the volume of the gas decreases, the pressure increases. This is because the particles collide more frequently with the walls of the container, increasing the pressure. The opposite is also true. Increasing the volume of a gas also decreases its pressure. This is represented by the equation PV equals constant, where P is the pressure in pascals and V is the volume in meters cubed. Boyle's law can also be represented on a graph. The graph shows that the volume and pressure are inversely proportional. This shows visually that as pressure increases, volume decreases, and vice versa, by the same amount at constant temperature. The equation PV equals constant can also be written as P1 V1 equals P2 V2, where P1 and V1 are the initial pressure and volume respectively, and P2 and V2 are the final pressure and volume respectively. This relationship is only applicable to ideal gases. You must be able to sketch and interpret this graph. Make sure you draw this in pencil as smooth as possible and do not have the line touch either axis. Let's see this in practice. The table shows a series of pressures and their corresponding volumes obtained in an experiment with a fixed amount of an ideal gas. The gas is at a constant temperature. Determine whether these figures indicate Boyle's law. Show you're working clearly for 2 marks. Let's first state the equation for Boyle's law. This is PV equals a constant. We can show that the data matches this equation by putting in some values into the Boyle's law equation. For example, a pressure of 60 multiplied by a volume of 2.50 is 150. The same goes for a pressure of 120 multiplied by a volume of 1.25, and so on. Therefore, we can see that P times V is the same value each time, or in other words, as P is doubled, V is halved. These figures therefore indicate the gas obeys Boyle's law. Sometimes the values may not be exactly identical. However, they should be equal when they're all rounded to at least 2 significant figures. In this case, 151.2 rounded to 2 significant figures will still be 150, so this is still equal to the constant. When you are given a table of data and a graph, make sure you use the values from this to back up any answers. Aim for at least 3 calculations. And finally, always make sure you write a conclusion for a question that requires you to prove something. This must be backed up by numbers where applicable. Let's try a more challenging example. A gas is contained in a cylinder enclosed by a piston. At first, the length of the cylinder containing the gas is 180 centimeters. The pressure of the gas is 410 kilopascals. The piston is moved to a new position where the pressure becomes 590 kilopascals. The temperature of the gas is unchanged. Calculate the new length of the cylinder for 2 marks. We have been given the initial length, the initial pressure, and the final pressure. We need to calculate the new length of the cylinder. We have 2 different scenarios on the same object, which implies we use the equation P1V1 equals P2V2. Now, we've been given the length and not the volume, but we know that this is a cylinder, where its volume is its cross-sectional area A times its length L. This can be replaced in the equation for V. A does not change when the cylinder changes length, as it is the exact same cylinder, so this can cancel out. We are left with P1 L1 equals P2 L2. Rearranging for L2 gives P1 L1 over P2. Now let's substitute in the values. P1 is the initial pressure, L1 is the initial length, and P2 is the final pressure. This gives a final length of 125 centimeters for the second and final mark. We know this is in centimeters because the units need to be the same as the initial length. In general, both pressures and volumes have to be in the same units respectively. If one pressure is in kilopascals and the other pascals, you must convert these both to be in pascals or both in kilopascals. You must know the volume of basic 3D shapes, such as a cylinder. This is its cross-sectional area, which can be of any shape, multiplied by its length. You must state the units if you're not otherwise given them in your final answer. Check whether the units are correct for the values in that question. Rearrange this equation carefully and make sure all your pressures P1 and P2 and volumes V1 and V2, or length in this example, are in the correct order. In summary, Boyle's law is stated by the equation PV equals a constant, or in another form, P1V1 equals P2V2, which is more useful when you have 2 different pressures and 2 different volumes in the scenario. This means at a constant temperature, as the pressure of a gas increases, the volume decreases, and vice versa. This equation is only relevant for ideal gases, which should be the case for all your exam questions. The graph of pressure against volume is inversely proportional. Don't forget to check out all our other fantastic revision resources here at Save My Exams.